I write a polynomial in standard form, it looks like ax squared plus bx plus c. So I'm not going to label these every time, but in case you forgot, a is 6, b is 41, and c is 70. Alright, and instead of having to remember all the rules of, well, this is plus, so signs have to be the same. This is plus, so signs have to be the same. All that, like both signs are going to be plus. Instead of having to remember all that, there's an easier way to me to have to do that. So what I do is some people make an X. I don't care what you do, doesn't matter to me. I just always use this chart. Some people see it as an X, and that's fine with me. I don't care either way. And what I'm going to put in the upper left corner, so up here in this corner, I'm going to multiply A times C together and put them in that corner. And since what is 6 times 70, just to remind you of the trick, in case you don't know it, I can multiply 6 times 7, which is 42, and add a 0 to the end. It's 420. And then I want to put 41 here. So 41's my middle number, and I got to break down 420 into something that's going to give me 41. When I multiply it together, I want it to give me 420, positive 420. When I add it together, I want it to give me positive 41. So from here, I don't know all the factors of 420 right off the top of my head, so I'm going to make a factor tree just to try to help myself out. So 420, easily I can break it into 42 and 10, and 6 and 7, that goes to 5 and 2, that goes to 3 and 2. Now here's the only part where you really have to guess and check, and it helps if you have good multiplication skills. Alright, so I need to mix and match things to try to figure out what I can do. Well, if I do 3 times 2 is 6, times 2 is 12, 7 times 5 is 35. So 35 plus 12 doesn't give me 41, so I got to try something else. So I need to mix and match pairs of these numbers, or sets of these numbers, to give me two numbers. And my goal, any grouping I pick of these numbers right here, if I pick any group, if I pick any set of these numbers to make two numbers, it's going to give me 420, because that's how. But after I found the two numbers that I need 6 is my number in front right now, correct? Okay, so what I want to do is take two sets of, these are going to be my parentheses, but I'm going to set them up as fractions to start with. I want to put 20 under one and 21 under the other one. And this is how I'm going to figure out what number needs to be in front of x in the parentheses. Just simplify the fractions. So 2 will go into 20 10 times, 2 will go into 6 3 times, 3 will go into 6 twice, 3 will go into 21 7 times. So I know that 3 is going to go in front of x with a 10 in the parentheses, and 2 is going to go in front of x with 7 in the parentheses. So my parentheses are going to look like this. So 3x plus 10, because this was a positive 20. That's supposed to be a 10. If I can write. And then 2x plus 7. Then you're done. Those are your parentheses. Alright. So if I do this one the same way I did the other one, I want to multiply 10 times 6. That gives me 60, not 16. 60. And then 23 is in that box. So I want something that multiplies to give me 60 and adds to give me 23. So 20 and 3 work. Alright, so I know 20 plus 3 is 23. And then 20 times 3 is 60. So there's my two numbers. Then I just have to make two fractions. And you don't really have to put the x on top. That's just what I do. It's just basically to simplify to see what I need to put in the parentheses. So here's 20. Put 20 on bottom of one and 3 on the bottom of the other. It doesn't matter which one's which because it'll work out the same. And then your answer is just going to be the 2 parentheses. The 10 will go in there one time, 10 will go in there twice. And I can't simplify 10x and 3, so I just leave it. So this is 1 times x, which is just x. And this is a positive 2, so I'm going to be plus 2 in the middle. And then this is 10x positive 3, so it's going to be 10x plus 3. And there's my parentheses. It has some negatives in it, so that's why I wanted to use it. So if I multiply 2 times, or a times c, a is positive 2 and c is negative 3. So 2 times negative 3 is negative 6. And then my b is negative 5. So I need 2 numbers that multiply to give me negative 6 and add to give me negative 5. Well, if I do negative 2 times negative 3, it gives me what? It gives me a positive 6. So the signs have to be different to give me a negative 6. Negative 6 and positive 1 give me what I need. Because negative 6 plus 1 is negative 5. So then I just set up the 2 parentheses. And make sure you carry the negative with the 6. And the 2x and the 1. So 2 goes in there 1 time, 2 goes in there 3. So my parentheses, and 2 and 1 don't simplify. So that's x minus 3 and 2x plus 1. And you kind of do the same thing the same way. The only thing you've got to check for, alright, if I have any 2 sets of parentheses, no matter what they are, I'm not going to use real. If this one's A and this, it don't matter what's in the middle. And this is C and D. It don't matter what they are, even if they're all different. To get the first term, I'm going to multiply A times C, right? That's going to give me whatever's in the front. And whatever's in the back is BD, right? So when I multiply those things together, alright, that's why we always put an x here and an x here, right? Because it's going to be x squared in the front. Well, the same thing, this is a y squared at the end. So both of these terms in the back are going to have a what? A y with them. And then, and that's going to work out the xy in itself. So anytime you see, anytime you see something, a letter squared here and a letter squared here, and that same letter's in the middle with xy, we're going to go over a formula to how to pull something out similar to that. But don't worry about that right now, because it'll factor the same way. So I'm going to erase this. If we need, so really what I can do is, since I know that y needs to go on the second term on both of them, just ignore the y for a second. I mean, you got to plug the y back in, but it'll be at the very end. Just factor it as x squared minus 10x minus 6. And then when we have the parentheses at the very end, alright, just add the y to that term there. And you'll be fine. But you can factor it like it's like this. But this problem also has something else in it that I want to point out. Anytime that we have a polynomial, you need to check. When you're factoring it, you need to check and see if you can pull out a number. For it to be completely factored, you need to be able to pull out. So, because if I can divide all 3 of these by some number, then I have to simplify it if I can. I can divide all 3 of these by what? 2. So really, this polynomial is 2 times 2x squared minus 5x minus 3, which we've already factored. It was the last problem we did. there. So really, I need to factor this and just stick a 2. So in my parentheses, the only thing extra I'm going to have is I'm going to have a 2 out in front of the parentheses. If I pull that number out, I still have to have it in the answer, because on the ACT they'll probably have an answer choice with the right set of parentheses without the 2, and then they'll have the set of parentheses with the 2. And if you're not paying attention, you pick the one without the 2 because you forget to add it back to the end. So, anybody have any questions on this problem so far before I go any farther? Then it's factoring just like normal. If I want to make the chart, which is it's -6 and -5, it's -6 and 1, which we've already factored that one. So that's why I'm going through it kind of fast. And then 2x and -6, 2x and 1. Alright, so my parentheses are going to be x minus 3, and since I need a y at the very beginning, it's going to be x minus 3y. And same thing for this, it's 2x plus, since this is a 1, you could put 1y if you want to, but I don't need it there. It's just 1 times y, which is just y. But you can put it there if you need to. And so, when I factor that out, this is my answer. If I do that, that's 2x squared times 2 is 4x squared, so that gives me that term. And then the last two things is -3y positive 1y, so that's -3y squared times 2 is -6y squared. And you can do the same thing and check the middle if you fold it all the way out. So does everyone see? If I have sets of parentheses like this and there's an exponent on the outside of them, then that's kind of like distributive property. I have to give this exponent of 3 to every letter and number on the inside. So I've got 4 to the third. Then I've got -3. I got x to the -3rd times 3. If a power is raised to a power, what do? Multiply. So it's -3 times +3, which is -9. And then 4 times 3, y is 12. Alright, and then c squared to the 3rd is c to the 6th. And then I've got 3x to the 5th, y to the -8, c to the 4th. Then here, if I multiply two things together, I just add the powers. Except I've got 4 times 3, or 4 to the 3rd is what? Off your paper, do you remember? Yeah. Test is Monday on that, by the way. It's 64. And then so you do 64 times 3, which is 192. Do what? For that. If you think it can't factor, you just double check and be sure. Most of the time you can tell. Most of the time you're right. But just do this: b squared minus 4ac. All right. If it equals like 0 or 2 or 4, or not 2. It can't be 2. 0, 4, 9, 16. What's in common with all those right there? They're. So this looks kind of like what 14 is, and what I mean by factoring the p out. So I took it out of both terms and put it on the outside. Then it's just like a difference of squares.